Good afternoon, student. Today I will be discussing with our topic calorimetry part 3. The topic that are to cover are state of matter, change of phase, melting and fusion, heating curve of ice, factor affecting melting and freezing point, vaporization or boiling point, factors affecting vaporization or boiling, heating curve of water, latent heat and specific latent heat. Student, now we'll be discussing on our first topic that is the state of matter. Now the matter are present in the three form. They are solid, this is a solid, and this is liquid, and this is gas. So in short we can say that matter exists in three states. They are solid, liquid and gas. Now there are some matters which can exist in all the three form. There may be anything. For example, we are taking here the water. Water can exist in the form of solid, that is the ice, and it can exist in the form of liquid, that is the normal water. And another is that water also can exist in the form of gas, in the form of vapor, that is the vapor. Okay, so there are some substances which can exist in all the three states of matter. Now we will discuss on our next topic, that is the change of phase of matter. Now since we have already understand that matter exists in three states, they are solid, liquid and gas. Now this state can be interchanged from one form to another form. Now when the solid is changing, this solid is changing to a gas, then we call this process as a sublimation. Now again, if this gas is changing into a solid, then we will name it as the process as an deposition or solidification. Now again, if we look at the solid and another is the liquid, between these two, if the solid is changing into a liquid, then we will name it as a melting. Now again, if this liquid is changing into a solid, we will name this process as a freezing. Similarly, if the gas is changing into a liquid, then we will name this as an condensation. If the liquid is changing into a gas, then we will name it as an evaporation. Now among all this topic, one thing is very common during the change. The very common is that during this change there will be no change in temperature, although there may be a exchange of heat, but there will not be any change in temperature. Why there is no change in temperature? This is because of the latent heat, and this latent heat we will be discussing on our further topic. Students, now our new topic is melting and fusion. In this melting and fusion, we understand that melting is nothing but the change of state of matter from solid to liquid form, and during the change in this state there will be no change in temperature. but there will be still the heat energy that is being absorbed, which is not detectable. This heat is because of the latent heat, which we will be discussing in our further topic. Now student, our new topic is the freezing point. Freezing point. Freezing is when the water or the liquid form is changing into a solid form by the losing of heat. Now we know that in this case there is an absorption of heat, but it is not manifested in temperature. In this case, in freezing, this is the water will lose the heat energies, and there will be no change in temperature, or there will be no manifestation in the temperature. So this is known as a freezing, and that is known as a melting. Now we will be discussing at the another topic, that is the freezing point. So the temperature at where the water changes, the state of liquid changes into a solid form without any change in temperature. Student, again now we'll be talking on our new topics, that is the heating curve of an ice. We know that the ice used to get melt at 0 degrees C, and again the water also used to get converted into ice at 0 degrees C. Now what is happening in between them is nothing but a changing in energy. Now this changing in energy is happening in such a way that there is no manifestation in the temperature. Now this is because of the latent heat. Now what is this latent heat? Latent heat is the energy that is required to break the intermolecular force between the two molecules. Okay, now in this figure we are taking here a graph. In this graph we have seen that from A to from A and B. From A to B there is a constant temperature. Now due to this constant in temperature, there is no change in the temperature, but there will happen that the liquid from here, the solid from A, when going from B, we will be seeing that it is changing from solid to liquid, but there is no change in temperature. But although there is an heat that is being absorbed, and after B, if we further increase the rise in if we further increase the temperature, if we further increase the heat, now we will find that there will be a rise in the temperature, and it will go more further. Now again we'll be seeing at our new topic, that is the change of phase from solid to liquid. Now from here in this picture we have seen that from A to B there is a increase in temperature, but from B to C there is no change in temperature. Again from C to D there is an increase in temperature. Again from D to E there is no change in temperature. Now from E to F there is again change in temperature. Now why it is this happening? This is happening because from A, when it goes to B, at that very time from B, at that very time the state will be still in the solid phase. Now from B to C, when we see the between these two, we will see that there is a melting taking place. Between in this place, we will be able to see that there is a composition of both solid as well as liquid. Now from C to D, what we see after, as soon as it reach the C, now what will happen is it will increase the temperature till 100 degrees C. It will increase till 100 degrees C, and from 100 degrees C it will not increase more in temperature, and it will stay very steady. And as a result of this, what will happen is, as a result of these things, there will be no increase in temperature. Now since there is no increase in temperature, but there will be a changing in the phase. The phase will be from liquid to gaseous form. It will happen to change, and from E to F there will be increase, and there will also be change in the state, that is from liquid to gaseous. It will start changing. Now the point B is known as a melting point, and the point D will be known as an boiling point. Now student, will be talking on our new topic, that is cooling curve of water and cooling. Then this is the cooling curve. Now here we have seen a graph that is being plotted over here. Now from 100 to 110 degrees C to 100, we will see only a steam, that is nothing but only a gas. So here it will contain only gas. Now as soon as we cool this gas, as soon as we start cooling this gas, what will happen after reaching at this point, from 100 degrees C to in this place, you will find that it contains a gas plus liquid. You will see gas plus liquid. Now again from this place, you will able to see that from this place to this place, here you will only see liquid. Here you will see only liquid. So this one will be considered as the condensation point. Now again from 0 to this one, from this place to this place, you will only see two things, liquid plus solid. You will both see liquid plus solid, and this is and from here you will see only an ice. You will only see an solid. You will not see anything, but you will only see a solid. So this is the only things you will find. Now from here we can tell you that we can know that during this point, let me take the pointer. Okay, from this point to this point there is no change in temperature, but from this point to this point there is a decrease in temperature. So by decreasing the temperature, we can convert the steam into an water. Again from decreasing the temperature from 100 to 0 degrees C, we can convert into a liquid. Again from 0 to minus 20 degrees C. If we decrease the temperature, we can convert it into a solid. So this is the information that we can get from this curve of cooling water. Now student will be talking on the factors that is affecting the melting point. Now we know that if there is a impurities, now let me take a water. Now say this is a water. Now you know that this water is having an anomalous expansion. It is having an anomalous behavior. Although if you heat it this one, then it is to be expand, is not? It is to be expand. But instead of taking this water, let's take about the ice. Let's talk about the ice. Now we know that ice is a solid. If we started heating here, then we will see that instead of expanding, it will started contracting. So this ice is having different property than that of the others. So therefore, such kind of substance, what will happen? Melting point of the substance will in which the contract like ice decrease with increase in the pressure. That means if you increase the pressure, the melting point will start at decreasing. But on the other kind of substance like this, okay, what will happen? The substance, the melting point will increase by increasing if you give more pressure. So we are talking about the pressure here in this case. Now second part will be talking about the impurities. Now suppose if there is an impurities in this any solid part. Now suppose this is impurities. These impurities, the presence of these impurities increase more melting points. So the presence of these impurities decrease the melting point. It will decrease the melting point. The presence of impurities in the substance will decrease the melting point. For example, you know this ice cream. So kulfi, so this is ice cream. This ice cream are consist of this salt, salt, so that the melting point can be decreased, and when it enter in your mouth, you can get it very easily. So it will get melt very easily, and you will able to enjoy the ice cream. So because of this reason, most of them are put with the impurities of salt. Thank you. So students here will be speaking on our topic, that is the vaporization or boiling point. Now vaporization is when the liquid is changing into gases. In this picture you are able to see that there is a liquid containing a container containing a liquid. So due to the heating, it will start changing into a gaseous form. Now this phenomena is known as the vaporization. Now what is boiling? So boiling is a temperature at which the liquid form is changing into an gaseous form. Then this is known as an vaporization. Okay, actually it is a temperature at where the atmospheric pressure become equal to the vapor pressure. Okay, so the main you can define this boiling point as a temperature at which vapor pressure become equal to atmospheric pressure, also you can write. Okay, so here the particular temperature at which a vaporization occur is called the boiling point of the liquid. So here I am writing in simple English, so you can write in this way also and that way also. Now we'll be discussing on our next topic, that is the condensation. Now this condensation is here is what this is a liquid. For example, this is a liquid, and what happened, because of too much heat the gaseous form is going on the upside, and later on this gas is getting converted into liquid again, and this process is known as a condensation. And the temperature at which this condensation take place is known as the condensation point of a vapor. And we know that for water the condensation used to occur at 100 degree C, and the boiling also happen in the 100 degree C from the curve that we have learned. Now we'll be looking on the factor that affects the boiling point. The factors that affect the boiling point are pressure on the surface of the liquid. Now suppose this is a liquid, and more the pressure it is, if it is more pressure, then the boiling point will be increased. That is why in normal case, when we boil the water in a normal atmospheric pressure, then water used to boil at 100 degrees C. But if we boil the water using the pressure cooker, then it used to boil at 120 to 125 degrees C. This means that with increase in the pressure there will be increase in the boiling point also. Now because of the effects of the impurities, the boiling point also will increase. So for example, while cooking while boiling egg, you see that our parents or your mother or your parents used to your mother or father used to do what, they used to pour a little bit of salt so that the impurities may be present there, and because of these impurities the boiling point of the water will increases from maybe 100 to 110. So at that very temperature you can boil the egg very easily within a very few time. So that's why we used to add the salt on the water while boiling the egg. That is the latent heat. Now this latent in this picture, to understand this latent heat we have to understand in this picture. In this picture we have seen that the ice is changing to water at 0 degree C, and again the water is also changing to ice at 0 degree C. Similarly, same thing is there, that the water is also changing into gases, that is the water vapor at 100 degrees C, and water vapor is also changing to a water at 100 degrees C. So during this process there is an exchange of heat, but now we know that although there is an exchange in heat, but there is no change in temperature. Now why is the reason this one why is the reason happening? The main reason of this is because of the latent heat. Although there will be a exchange of heat energy, but there does not show any change in the temperature, because the heat energy that is being used is used for breaking the intermolecular attraction between the molecules in the compound. This heat that is being exchanged during the changing of state but does not get manifest is known as the latent heat. Now what is the latent heat? In the definition we know that latent heat is also known as the latent energy or heat of transformation, is an energy released or absorbed by a body during a constant temperature process. Which change from one phase to another phase. So by looking at this picture itself, by looking at this diagram itself, we can understand what is a latent heat. So the thing in science is we only need to understand. Now let's look for the specific latent heat. Now suppose we are having a specific mass, for example say 1 kg. Now whatever the heat energy is required, okay, to rise, means without any change in temperature. So this heat energy is required for changing from one state to another state, and this mass is the mass of the substance. Then it is known as an specific heat capacity, or specific latent heat, or we can say that specific latent heat of a substance is the amount of energy required to change the state of 1 kg of the substance without changing its the temperature from one form to another form. Okay, so this is the definition of specific latent heat. Now actually why does this why there is no change in temperature? By definition, from the previous video we have already understand that the latent heat of the temperature is nothing but an average of the kinetic energy. But during the change in the state, the average of the kinetic energy does not change at all. That's why there does not show any change in the temperature. For example, you see here, now this is a liquid and it want to change this into a solid. Now in this case, the distance between the molecules are very apart from each other. Now as a result of this, when changing from this one to this one, the kinetic energy at this case and this case, average kinetic energy remains same. Why? Because in this case, although the kinetic energy is more, but still there is a big volume here, means there are many space between them. But in case of solid, you see here is they have got a kinetic energy, but the potential energy is more stored in this case. So as a result, the average kinetic and potential the average kinetic energy does not change. So there will not be change in any temperature. Similarly in this case also, in liquid and in gas also, you just see here the space between them is very much, here the space between them is very less, but the movement in this case is more, but the movement in this case seems to be less. But since they have got a more distance between them, their average will be same. So the average kinetic energy means same, means there will not show any change in the temperature. Similarly this one, it is a solid and this is a liquid. So in a latent heat there does not manifest any change in temperature. Why? Because the average kinetic energy during this stage remains same. That is why there does not show any change in temperature. So student, if you like my channel and if you like my explanation, please do like and subscribe my YouTube channel, so and also share with your friends so that they also can get benefited from these videos. Thank you.